All right, welcome, and I'm going to continue talking about electron configurations, but now, as promised, I've been holding this back for basically the whole chapter, and now I'm going to get to it. This is kind of finally the thing that makes everything simple and kind of wraps everything up in a neat little bow. So, I've been telling you the whole time, don't waste time memorizing the order of all the subshells. Don't waste time with that. Don't waste brain power on it. Don't worry about it. The information you need, that information is all embedded in the periodic table itself. It's all just sitting right there for you to know and look at. You don't have to memorize a thing. So, the filling order, right, the order we go in, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, all of that is all in the same order for every element ever. All that really matters is where you stop. And what's cool is the way I rattled that all off, knowing that order, I didn't memorize that. I'm not doing it from memory. I'm actually sitting here staring at the periodic table. And that's what I'm going to teach you to do. I'm going to teach you to look at the periodic table and know where know how to write the electron configuration, what order to go in. So there's a concept called the distinguishing electron. And the distinguishing electron, it's kind of an abstract thing, but it's just the last electron added to the electron configuration. It's where the last one is. So it kind of, the way I think about distinguishing electron is if you look at, the electron configuration for, say, oxygen, 1s2, 2s2, 2p4, it's that fourth electron in the 2p, right? We're talking about where you stop in going up this electron configuration, right? So here's the cool thing. All I need to know to make writing electron configuration super easy is two things. I need a way to know the order of the electrons, or the order of the subshells, I mean to say, and where to stop. If I can do that without having to sit and count out electrons, right, then this would be easy, right? All I need to know is just know the filling order and where we stop. And that's it. And I'm going to show you how to do this from the periodic table. Okay, let's look at a periodic table here. All right, so you may have to look at some reference material because I'm going to show you this, but I'm going to show you, we're going to look at the elements and think about how, we write their electron configurations and where they fill, right? So hydrogen is simple. Just a moment. Kind of messed myself all up. Okay, there we go. Better. So if we start at hydrogen, it's 1s1. Helium is 1s2. Lithium is 1s2, 2s2, right? So here's the thing. What's happening is, notice how we've got these two blocks here, and we have 6 blocks over here, right? I should say this, 6 blocks here. What this is, notice this correlates really nicely to how many electrons fit into the S subshell. So right, how many electrons maximum fit into the S subshell? It's 2. And this block happens to be 2 blocks wide. So we call this the S block, right? Now this one is 6 blocks wide, which 6 happens to be how many electrons will fit into a P subshell. I'm not talking about an individual orbital, I mean the whole subshell, right? Because there's 3 orbitals in a P subshell, and therefore 2 electrons per orbital, and therefore 6, right? Now this down here, this part is 10 blocks wide, and I hope you see where I'm going with this. This is the D block. And down here is the F block. What ends up happening, because the elements are put in the periodic table in order of increasing atomic number, this correlates nicely. If they're neutral, this is their number of electrons. So what we have, the periodic table also is this neat little way of counting up all the electrons, right? And organizing them as to where they go. So if something ends in the S block, you know its last full subshell is going to be S, right? Its last full subshell will be S. If it ends in the first block, right, and I showed you this, all of these in the first row, what makes them all similar is they're all going to end with something S1. If they're in the second block of second, column of the S block, there'd be something S2, right? Now, what that N is depends on which column they're in. So let me break this out a little bit more. Here's where we end up. We end up looking at this. So here is the block, taking all the elements out. We end up just counting, right? So anything that ends up here, right, notice that we have that the S's, right, the S's all track perfectly with the period number, right? So something that ends in, well, let's look at here. This is calcium, is this block here. And so we know that the distinguishing electron for calcium is going to be 4s2. All that's left to do now is to fill in all the stuff before it, right? Now I know where I stop. Over here, in the P block, right, it also correlates perfectly with the period number. So say, let's do something really out there and obnoxious like tin, which tin lives here, right? We know it's going to end on 5p, and we count how many blocks in it is. So it's 1, 2, it'll be 5p2. That's where tin will end up. That's where its configuration stops. That's the distinguishing electron for tin, right? Now, these are a little tricky, because remember, when we fill up an electron configuration, we go, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, right? So after 4s comes 3d. So in the D block, the D's are all behind by 1, right? So if you're looking at the periodic table, you can remember that the S and P blocks there, if you're looking for the distinguishing electron there, right, the number before the P or the S matches the period number. For D, it's period number minus 1, right? So let's say gold is right. Well, actually, let's go back to the periodic table that has all the elements on it. That'll help. Looking at gold, right here, right, we know it's in the D block. So it's going to end on something D something, right? Well, now I got to figure out what what the number out in front of the D is, right? So, I said I'm looking at silver and I'm saying gold. I'm sorry. Let me just pick one for sure. Let's do silver. Let's do silver. Let's do this one, element 47. So it's in the D block, and it's in period. It's in period 5, right? But the D blocks are all behind by 1, so it's going to be 4D, and then we have to count in 1, 2, 3, 4, 5, 6, 7, 8, 9. 4D, 9. That's where it's going to end, right? So all you do is you can find the distinguished electron. Phosphorus, it's 3p3, right? Bromine, 4p5, right? Strontium, 5s2, right? I'm doing this by just looking what block it's in, where in the row it is. If I went all the way down to uranium, right? Now this is uranium's a little obnoxious because you have to remember that, so this goes here, this goes here, so this is actually row 7. The F's are actually behind by -2. So this is something F, it's actually 5F, right? 7 minus 2 is 5. and 5F 1, 2, 3. 5F3. That's where it's going to end. Okay. Now we got to talk about filling in everything else, right? Well, this is why you don't need to memorize that filling order. Because when you look at the periodic table, when you start learning to look in this way, you can just see the order, right? Because if you walk yourself all the way from, one electron and start filling up, you're going to walk through all of the shells in order. So the reason I know what the order is I just go, we start at 1s. And then after 1s, we go to 2s. And then we go to 2p. And then 3s. And then 3p, right? And then 4s. And then how do I know 3d comes next? Well, I end up going after the 4s's, potassium and calcium, I end up going through the d's, and I know that it's behind by 1, so it's 3d, 4p, 5s, 4d, 5p, 6s, and then we have to go down here, because these blocks are actually here. Then it's 4f, 5d, 6p, right? 7s, 5f, 6d, and so on, and finally 7p, which actually do now exist. So, but that's how I know. That's how I do this. So, don't need to remember the filling order. So again, just one more example. Selenium. I know it's in, so let's look at selenium, right? Selenium is here. I know its electron configuration is going to stop with, it's in the P block, so it's going to end with something, P something, right? It's in the 4th row, and P's, their shell numbers always match the row number. Remember? S and P, their shell numbers match the period number. D's are behind by 1, so they're period number minus 1. So this is period 4. This is 3D, 4D, 5D, 6D. F's are behind by 2. So this actually goes with period 1, 2, 3, 4, 5, 6. So this is 4F, 5F. Right? So I look, and arsenic is in the 4th row. So I know it's 4P, and it's, oh no, I said selenium. Selenium, 1, 2, 3, 4 in 4P4. So that's how I know. Oops, not what I want. There we go. And so, why did I write 4P5? Okay, all fixed. 4P4. Fantastic. Okay, so to actually write this electron configuration of selenium, as I was saying, is we just walk down the periodic table. So I start with hydrogen and helium, which are in the 1s. So 1s2. Then move through lithium and beryllium. 2s2. Go through the next block. Right? So I'm just going to move through the periodic table, and this tells me what all I need to do. And that didn't get saved for some reason. P4. So, there it is. Maybe it'd be easier to just show you. So, I want to write the electron configuration for selenium. I start up here. 1s2, and I just fill everything except for the last one. 2s2, 2p6, 3s2, then over here to over here, 3p6, then down here, 4s2, 3d10, and finally over to selenium at 4p4. Right? Now, noble gas notation electron configuration is a lot easier because we don't have to start all the way at the beginning. When you're learning to do it this way, noble gas notation, you just go back to the previous noble gas. So you have selenium. Well, I just need to go back to argon. So I'm just going to start with argon, and then I'm going to go argon, and then we end up going through 4s2, and then I go through 3d10, and then 4p4. Right? Very simple. Maybe not simple, but it makes everything easier than the way we had been doing it. So, all right. Here's the same thing, And now I'm just going to end with looking at these. So I want you guys to try these. I'm not going to flash back to the periodic table. You should get one in front of you and look at it. And I'm going to go through the period. So try to figure these out. And just do the noble gas notation. That makes it easier. Right? For the record, when I say on an exam, if I don't say which way I want you to do electron configuration, you can pick, which I bet you'll probably do noble gas because it's easier. So, tellurium, number 52. The previous noble gas is krypton. After krypton, we go to 5s2, right? Then 4d10. And then finally, it's just below selenium, so it's going to be 5p5. Nope, not 5. 5p4. It's 4 blocks from the left of the p block. Strontium. Nice and easy. Previous noble gas, krypton. It's the second, element in the 5p block, 5s2, or 5s block. Sorry. Silver. Already did silver, but let's do it noble gas notation. I'm picking all these ones that are krypton. And then so we start with 5s2, 4d9, right? Finally, osmium. A little bit farther. We're going to go to xenon. Then we're going to osmium. So next is 6s2. Then we have to go through that block at the bottom. We have to go through the inner transition element. We have to go through 4f14, right? Because remember, there's 7 orbitals in an F subshell. Then I can go through 5d, 1, 2, 3, 4, 5, 6. Okay, now one last thing I want to tell you. Some of you guys might find a periodic table somewhere that tells you the electron configurations, and it's not cheating, but I just want you to know you might find some, particularly with F's and D's, you might get some things where you might look on a periodic table and it shows you, so some of you may be tempted to come ask me, why when I look this up does it show me that the electron configuration for chromium is, because if you were to look up chromium, you would find argon 4s1 3d5, which violates everything I've told you, right, about how electrons fill. This actually happens, but I'm not going to get into why. You may look that up on your own if you're curious, but I'm not going to talk about why. Don't worry about it. I'm sticking to the basics. So there you go. Hopefully that helps.